live on YouTube, so I'll start the countdown.
I'm kinda like complicated. I never know what I'm chasing. No, I don't need.
Hello everyone, welcome to the stream.
But you appear like a lightning bolt.
We have with us Maddie, Paul, and Damien. We're going to talk about layout and scene authoring. I'm really excited because I learned a lot from these, so I can't wait.
It'll be fun. We have a good show. If the demo gods are with us, we'll have a good demo as well.
So Damien, are fireworks a common part of Canada Day?
There was there was no firework on Friday. I didn't. I slept well, at least. We're having a good weather, so we're really happy here.
Paul's got good stories about fireworks.
We went, boy, a long time ago, probably a decade ago now. We went out. There's a beach in Washington called Long Beach, and it's you can drive up on the beach and stuff. And we went out there for the 4th of July, and I can't tell you how many fireworks there were. It was just like everybody was camped. Like every 6 feet there was another fireworks display, plus the city one. And I remember we were parked off to the side a little bit, and there was just stuff raining down on us, just like pieces of old fireworks raining down on us. And then my son and I decided we were going to try to walk down through the beach and touch the water and come back. And it was pretty crazy. There was just like all sorts of stuff flying around. So it was just an overwhelming amount of fireworks. It was kind of crazy. So I want to go back and do that again sometime. Didn't lose an eye, didn't lose any fingers. So it was a good outing.
You did it right then, right?
Yeah.
Well, there's pretty good, particularly in the latest version of Create, so someone can make a safe version, digital twin.
Yeah.
I like it. I like it.
Then you can
Let's
have
do a live
fireworks
stream.
whenever you want, too.
Make your fireworks show in Create. Be safe. Stay
Yeah.
home
That's right.
from your gaming chairs.
We have the audio API and schema as well, so you can
Oh,
get your
yeah.
explosions.
Yeah, have some good water. You can do it on the beach. That's good. I like it.
Yeah, I was looking at some scenes from Machinima, and then, start playing to get the animation. Then suddenly it's like, blah, 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 there's music, and I was like, what? But yeah, you can do sound. It's great
Yeah.
too. I was trying to solve my Rubik's Cube while I was waiting, and then toward the end, I was just like one false move, and then that's go back to square one.
I used to run a side business in elementary school to solve people's Rubik's cubes.
Oh, really?
Yeah, I can't actually solve them. What I would do is I would take the corner off, take all the pieces apart, put it all back together,
That's
and bring
what
it
I
back the next
eventually
day.
do. I start
These
with
days,
the intention.
There's good resources, right? So solving it fast is difficult. Solving it, you get to learn the actual resources, the codes. It's okay,
Yeah.
but yeah, doing it in like 15, less than 10 seconds, those are like
Don't they sell the stickers? You can use the stickers, right?
Oh, yeah. You could just take the stickers.
Well, back
That's
in the
really
day,
cheating.
that didn't really work. It didn't. I tried that first. Taking it apart was better. Yeah, I saw a guy juggling. He had 2 or 3 of them, and he was juggling and solving them while he was juggling. Right?
it would probably take you less time to learn how to solve them in a couple of minutes, because after you could just solve them for real and you make more money.
Yeah. Well, I mean, back then it came with a little printout of like, here's how you turn things. Like there was no like internet. I mean, there's BBSs, I guess, you know.
Well, my daughter wanted to learn, so I'll learn with you. So I learn how to do it. It takes me 3 minutes or something, and I have to concentrate.
That's amazing.
So it's not really like magic fingers, but.
That's cool.
So hello everyone, welcome to today's stream. You can see Edmar getting set up over here. He was having a little bit of technical difficulties, but he's here with us. We have Paul Cutzinger, we have Mateus, we have Damien.
Hey!
For our developer stream today, going over layout and scene authoring. I love these streams. There hasn't been a lot of them, but I have learned so much from just watching these streams, so I'm super excited about it. Let's see. Edmar, are you
I'm here? It's working.
We want to, I guess, make sure everyone's aware of SIGGRAPH. We're going to be at SIGGRAPH this year. So everyone, all of our community people, we're having our user group. We'll be there live to talk to you. We're talking with a bunch of our partners, and we're talking about what's going on in the community. So really, really would like to see you guys there. You don't have to go in person. You can watch it online. We will be streaming. So make sure that you're a part of it. Edmar, was there anything else that we needed to talk about?
Yeah, on SIGGRAPH. So we're going to be releasing a list shortly of kind of who will be there in terms of our partners. So we would love to gather questions from the community because Wendy and I are planning with our team. Maddie and Vince will be there. We're planning to kind of interview some of our developers and kind of like just kind of on the site live stream. So we'd love to have a list of questions from the community for some of our partners. So we'll put together that list and we'll share that with you. And like Wendy said, you could be listening in virtually, watching virtually. You don't have to be there. But we'd love to involve the community as much as possible. One thing we'd love to do is trying to look for community content right now so we can put together a little sizzle reel of the latest stuff that people have created in Omniverse. So whether you're a coder, whether you're an artist, an architect, whatever your field is, if you're using Omniverse for something, we'd love to be able to show it off to the world at large. So the best way to do that is submit it to the Omniverse Gallery. So just search for NVIDIA Omniverse Gallery. It'll come right up. You could give us all information. We'll know exactly what you used. And then if you'd like, you can also ask Wendy, myself, or Maddie questions on the forums or on Discord, and we'll help. But that's our main announcement. And then hopefully soon, the judges right now are about to go through all the submissions from the Machinima contest. We've gathered all the files and all the notes on everything. So that's super exciting. So we'll have more to share that very soon. And if one contest ends, that usually means historically that there's something else coming. That's all I can say. But this is going to be a fun one. So that's it from me.
On SIGGRAPH, that'll also be the first time that we're going to do in-person workshops for extension building. So a lot of these topics we've been talking about in this stream, we'll be able to have some in-person topics there.
That's awesome. Yeah, if you are going, it would be great to actually ping us if you are going. Send us a direct message, one of us on the stream, and we'll share some details of some of the stuff we're doing there. And we'd love to meet you. Okay, so who wants to introduce this special show today?
I will go ahead.
All right.
And get started. So today we're talking about scene layout and scene authoring tools. Omniverse is all of our Omniverse apps are built on Kit. Kit is the application development platform where you can build new apps with the technology that we have in Omniverse. You can also build extensions for any of those apps, which are essentially our plugin system. So you can extend the functionality within Kit and within Omniverse apps in general. And so today we're talking about building extensions with the purpose of being able to procedurally author and manipulate our scenes in Omniverse. So with us, we've already mentioned we have Damien and Paul, but I do like to have you guys introduce yourselves. So Damien, if you could start out.
Yeah, hi everybody. If you're a newcomer, we are welcome to this show. You'll enjoy it. If you're returning, we love your steadiness into attendance. Yeah, I'm Damien. I lead the Omniverse Kit group, and so we're here for you to build the platform so you can express your programming creativities.
Thank you.
And hi, everybody. I'm Paul. I'm the Exchange team. And so Exchange is the place you go to get all these cool tools to build all your workflows. So that's where your extensions and your connectors that you all build will show up and be exposed to the community to use.
Awesome. So without further ado, let's get into layout and scene authoring tools. Damien, what do you have to show us?
Okay, that's great. So I'll start sharing my screen. We have a great bunch of things to show. So I'm really excited about that. So let's just see. Share the screen. Go live. So my co-host will let me know if you're seeing my screen in all its glory. All good?
Yeah, you're up.
Okay, perfect. Okay, so we've created that samples. It's still you'll see here still private, but soon enough you'll have access to it. And so we're trying to create these samples, and we show if you've been here the week before, you will see us showing different types of sample on the previous chapter that we had. Remember, and we'll go over them today. It was around creating amazing window. And then creating scene manipulator. And so we'll look a little bit today on a new type, this sample around scatter, that tool that do scene authoring. Again, those samples will go public, so you'll be able to see them. We'll go over the code in a second, but before we do that, I thought the best would be to show you what it does. So I've prepared these scenes. I'm going to show you briefly the purpose of these tools. So we have a scene. It's in one of these beautiful environments that come with the platform that you can activate, where you have great, beautiful shadows. And I've just created a cube here in the center of that stage. And so the tool is creating that window. And it's really a reference, a template for you to kind of learn how to create tools that will enable you to modify the scene. And so we have these different elements here. We have the source of the scattering. Here we've picked a cube. I've picked this aligned cube that is here in the center of my scenes. It'll create it in some Prim. It'll create reference. We'll see that we have a couple of things we can do: reference, copy, and point instancer. We'll go over all of them, but we'll do reference and point instancer. There's some randomness, so we show the seed, how to use it, and then we just say, how many objects do I want to scatter on the x-axis, on the y-axis, on the z-axis, over what distance and at which randomness. And then when you press scatter, it's going to run a function. Again, we'll go over the code. I just wanted to show you a little bit so you have some concrete visualizations of what it does before we go into the code. So I'm pressing scatter. It's computing, a bunch of positions. It do a lot of copies, and now we have all of these reference of that initial cubes, right? So now I've got these 25 cubes, 5 by 5, and they're all in that little group. And so the code will see how we take these cubes, the one that is aligned here, and then we reference it. In USD, you can do reference on the scene itself, right? They could be reference of assets that are in a different file, and we'll see how they look. But also you can do reference in your own file. So sometimes it's nice. It's like a little bit of an instancing of the asset that you have in your file. So you don't have to reference external file, which is what we did here. We effectively created 25 copy of that scene in that organized structure. So I'm just gonna undo that creations, and then we'll just modify a few things, right? So for example, we want to add some randomness. So I'm going to do 200 of units of randomness in the x-axis, 200 in this axis, and then now these cubes get, the things get calculated, they get rendered, but you see they're a little bit scattered. 200 still not much, but you see they're a little bit scattered. Again, we'll see at the code how that works. So of course that's interesting. That's just a simple cube, right? Once you do reference, you would want to do reference with a bit more interesting things. So what we'll do is we'll hide that cube, and we'll look at two other objects that I have in that scene. There were some of these cardboard. They're actually pretty well models. There's, if you were to look at the wireframe, they have nice chamfered, and they're nicely textured model. But they're cardboards. They're from our industrial library. And I just picked two to show that you can scatter more than a single object with that tool. Then same as before. I'm just gonna go there. I'm gonna select these two cardboard, and I'm gonna say, oh, those are the Prim. The Prim is the sort of the object in the world that I want to reference in that scattering. I'm just gonna remove that in here. Those Prims are a little bit smaller, so I'll just do it on a smaller distance here. These two will do 5 by 5, and I'm going to scatter them. So here, what's interesting is, now I've got these 25 bucks, but of course now this is these bucks that are a little bit more complex. Also, one thing to notice is these card box, they actually were originally references. So then you can start modularizing your scene. So when you build scene authoring in USD, you really want to leverage the fact that you do reference. So now you'd see that this card box is actually a prim that is inside our asset catalog. It doesn't really live in that scene. It lives somewhere on this S3 bucket. And so it was referenced already. I just use a transform to place it. So sometimes you can use that to place it in a particular place. I want it to be really aligned with the origin. So the scatter tool worked well. And then these reference are, reference of my thing inside my world. But of course, they are reference of a reference where the file lives somewhere else. So again, here we see that we are creating a little bit more complexity. Again, just undo a couple of these changes. And then we'll see how the code's done. Interesting, we've kind of seen now we could do these box, we could do some of them. The final things I wanted to show is that I wanted to show more reference in term of count, and also increase the complexity of the assets. These pieces of chess, I found them into the NVIDIA asset library. You'll find them into the extension. They're actually very complex, really well modeled with a lot of fine detail and really smoothed out geometry. If I go into the wireframe modes, you see that actually, this is the wireframe is just really solid because there's so much detail, right? They're really smoothed out to be beautifully round and things. So these, just show them again without the wireframe. These have really a lot of details. In the statistic, you see that this simple scene here already is showing 2 million polygon in these, pieces. So they are really high detail, but just show that you could pick, geometry, and then again, remember they will be referenced from the disk, so they are not saved in your scene. So, okay, we have this piece of geometry. So now that's interesting. I'm gonna select all of them, and then I'm gonna add them to the list of things that I want to reference. Instead of using the reference from the scene, because they're quite complex, and I'm gonna use this point instancer. So point instancer is generating effectively a point cloud, a lot of positions and rotations in scale. And then at each of these points, you can instantiate a particular primitives, right? But they don't get copied, and it's a very lightweight way to make a lot of primitives. So for that matters, I'm going to make 100 by 100 in that thing. And then we'll see 100. I think this one that we're doing by 50. Just you have to kind of scale up your things. And then I'm going to zoom out a little bit, and then I'm going to scatter them. Right? Yeah. So now you see that we've built all of this. So you see actually the size was a bit big. So let me just undo that. So undo is really important when you build tools, because you want to be able to let your users try things and retry them. So that looked a lot better. So now remember, this is 100 by 100s instances of that things. You see that was pretty fast. And then now I've got 2 billion polygons, right? Here as the statistic tells, 2 billion instance triangles, but there's still quite a lot. And then you see that each of these pieces of geometry is, the wireframe that we talked about before. They're really almost solid wireframes. So that's really great. And so here it looks, great. We have quite a lot. So I'm just gonna push the limit for that demo, and after I'll go back into the code. I just wanted to show 1,000 by 1,000, and then launch that. Here what happened is, and we'll see the code, it generates this 1 million random positions, although there's not a lot of randomness in Python. So that's what's taking a little bit of time here, really. We'll see, you could start watching our video on warp or this type of things, so you could see how to make that distribution a lot faster. But when this Python path really, which is most of what takes the time, is finished, we will see our scene that is, those 1 million. So if I zoom out, now you see that this actually 1 million of these little prims that we've looked at, that each of them are, almost 1 million polygons. And then here, when we look at the statistic, now we've created that one primitive, and the primitive scatter is the one that hold these entire worlds of instance geometry that is 246 billion of polygon. And you see that RTX is still very happy with that. It's still running at almost 60 frames per second here. Just go into some places here where it looks a bit, where we can see them a little bit. And then after, you could build something pretty where you would activate our next depth of field, and then get some beautiful view into your world. Okay. Great. So that's the thing. Now I'm going to go into showing some of the codes on how that was made. Cool. So if you have questions, make sure to ask them. I know Matti will drive us into the right directions, right? So ask question in the channel. So in order to do that, what did we do? So we created extensions, like we discussed always. Is really easy. It's a simple extensions. It doesn't have even that much code. It's still pretty simple. We leveraged the window extensions that we shared last week. So you'll see a lot of things that are common, right? You have these extension toml. If you haven't been with us before, an extension has this little manifest that shows, what are the different type of property, what does it depend on. These extensions really mostly use the UI and USD, and then it's called, UI scatter tools. And then in the code, we have very few things. In the entry point, we define a command. We'll see about the command. It's a really interesting way to do undoable things. And then we define these extensions, these scatter window extensions. So again, if you've been with us, this is the same almost template that is in all of our other example, almost unmodified, right? A couple of names were replaced just for accuracy, but effectively it does exactly the same as before, apart from the fact that in this particular example, it's creating the scatter window that we're going to see. Where is it? It's in this here. The scatter window is the window that get created. And so that's the window that we've seen. I've just collapsed a couple of the code here. We build a window, very simple window, right? We build the source. Let me just go back and forth there so you can see. So we build these different things as separate pieces, right? So here we have source, scatter, and a couple of axes. So in the code, we've said we build the source, we build the scatter, a couple of axes here. You see, you can template your code to make it easy. And then these things are themselves very simple. A little bit of a frame. We had that things on the UI, a couple of fields for the name of the field, maybe a little button that have some action. You've seen me get the selections to store it into the buttons. We have this UI that is a little bit procedural, right? Based on the axis ID and the axis name, it will create this collapsible frame. So we can call this UI 3 times, and then it will do for axis X, axis Y, axis. And so you can minimize your amount of code and maximize your efficiency to update it in the way. And then when we press the button, this UI button that's at the bottom, it will just call the function on scatter. So if I go there on scatter, you'll see that here we just go over some of our models. We figure out which are the prims that we have set that we want scatter. We run the scatter function. So I'll just go briefly over. That's really just a small utility. Here it's really for you to implement some really interesting ideas of building some arrays of transform. And then we run that code that will duplicate primitives along a transform and a set of primitives and use a couple of different duplicate type. So the UI code, 160 lines of code, and really is really largely based on the template that we've shared last time with just a few additions. Remember, we talked about the styling. You can very easily modify the color of the buttons or the spacing in various things. Here, what we did is we really minimized the amount of custom styling to just few things, just so it looks more like it is in Create by default. But if you wanted to blend a little bit, making a really cool looking window and then the scattering, then you would enhance this customization here. Then one of the functions that get called is scatter. Again, really here you see there's nothing very revolutionary. It's just a couple of loops embedded in each other to randomly generate a set of positions and ID inside the object list that we're going to use to create our instances. But here you would do some interesting scatter against a curve, a scatter on a geometry, a scatter that also use textures to be able to curl or density map, right? You can do a lot of really interesting things. And actually there is an example, and we'll follow up in the thread, that's called a surface instancer in the Kit applications that you can look, that is a lot more advanced in sort of that directions, including the paint tool. Here, scatter is really left for you to kind of think of how you want to distribute something in a clever way. Here we just show some example of a really standard grid distribution with a bit of randomness. And so that's kind of the most gist of it. I'll talk of the command in a bit, right? Is you create a window that's going to be your UI. When you create your UI, you define a bunch of these models. These models, they will represent the backing for what's in the slider or what's in the combo box. So you'll see this is a good example on how to effectively have variable for each of the value that are stored into these sliders, and that will automatically update. And then when you press the scatter functions, you press on that buttons and you trigger the action that you're planning for, you'll be able to pull these value from the model. So, you know, which are the source prims, which are the distances, which are the count, the different things. Again, it's pretty well explained. It's pretty easy to read and the code when you have access to it. So that's it. And then you call that command. So we'll look into a little bit into that command actually, and just show that. So duplicate prim here. We'll have a couple of paths, couple of modes, right? It's either we do this point instancer, and then we discussed a little bit about it. This is a special way to instantiate a geometry, or a set of geometry, should I say, a set of primitives into a very large array of points, you know, up to, you know, many, like few millions. I can't remember exactly what's the exact limit for a single one, but certainly we just see 1 million still working really well. And then the other path, which is not the point instancer, which is what we were showing at the beginning, we just do simple traditional sort of updates inside USD. So when you look at that code, you'll also be able to see that one of the way that we recommend you use USD to modify it is to use this command. So there's quite a few commands. There's actually, let me just show it here. There is an extension called Omnikit window command that's in default in code, where you can show all of the different commands, and then you can search through them and figure out all of the one that exist and where they're coming from and these type of things. So those are the commands that you really want to use. And here in that example, we would get the USD context. It's what sort of enable you to make this command in the right stage. And then we execute these commands, right? So we create prim. Here we're creating a scope. So in that mode, we were creating a little group. A scope is like a group. You could also create a transform if you would want to be able to move them all together. And then we go over the list of transform. Remember, this transform is the one that we've created into our command. Again, here, all of it is really for learning and you to discover. You'll do your own logic. And then from this transform list, we extract the actual matrices, and then the matrix and the ID. And then we call command again under that prim to copy a prim. So copy will actually make a duplicate of that prim. So you have full control over that copy, but of course it comes at a cost of memory. Or you can do a reference, which executes a different command. It creates a reference to that prim, which will effectively be not free of memory. You still have a transform, but it'll be a lot less memory costly, but you only have one real copy of your mesh. So if you were to change the material, it would change everywhere. So sometimes that's what you want, sometimes not. And so here you'll see some example of using these commands, and then we transform that prim to place it exactly where we want. So here a bit of an example on how to use command. These other ones interesting because each command, what they do is they add themselves into the command queue, and so that's what's enable you to do this undo. When we were doing the demonstrations, we talked about it. I create something, and I'm like, oh no, I don't want that. Then I just do Control Z, and then hop, it jumped back to where it was before I did the command. But when you do scripts that use many commands, you know, like here, you create a prim, then you copy a prim, then you transform a prim. If you were to do it naively, especially when you do it like hundreds of times, then you would do undo one by one, right? Because each of these commands get added to the queue and then they would show. What you want to do is you want to do this undo group. They're effectively going to group all of the command within that statement. You should be familiar with that construct from Python now if you've been using omni.ui with this group. And while this things is in context, your group is the group where all these commands lie into. All of these commands will fall into one single group. And so when you undo, you will be able to undo them all at once. Let me see if we can see them in the UI here. We might see that we have some of these groups. Maybe I undo them. Yeah, group. So you see here, I've got a group, and then it's a lot of prim, because what I did is we ran that script that we just seen, and it created a lot of this prim. And so while I did them as a group, I can undo the group and it will undo this entire thing, which is exactly what I want. So that's one way to use command that already exists, right? But now, what if you want to build a command? And so we have an example for you as well here. In that context, there's no exact command that was doing what we wanted in order to create the scatter create point, the point instancer. And so we created one, and it'll be a part of that reference sample. So let's see how these commands are done. They're really easy. You'll see it's really, again, 70 lines of Python code, pretty easy to understand. What you do is you create a class. A command is an instance of a class that derive from the command and some other utility helper if you need to. The basic requirement is to derive from the command class that give you some of the base functionality. During the initialization, you capture some of your parameter or some of the stage state that you need to. So here we see we just pass a bunch of these parameters that we have require for our executions. We do a little bit of processing, and then we store internally some of this processed data in a way that will be easy for us to do the action and undo the actions. During the do command, which is what will execute almost immediately after you execute your command, you actually do the forward actions. So you will get the stage. Again, there's a little bit of a utility there that's part of the one that we've seen here, which is called this stage helper function. The stage is the area where you're going to store all of your USD files. But you can have multiple of them technically. And then here we're using the USD API directly. We're not using command here. We're inside a command, so we'll have benefited from that. And so here you can look at the USD documentations for some of these documentation there. But effectively, we're using USD geom, which is where you're creating geometry, and it gives you access to some of these schema. The point instancer is the primitive type that we are interested to create, and we define what as specific positions. Then once we have this instancer, we get the object and we create a couple of attributes. When you're creating point instancer, you have to create a couple of positions and proto indices, and then a couple of targets. So this will do that for you in that command. But here you could use any type of USD API that you would want directly, and then this will do your command forward. And then later, if someone press undo of your command in the stack, it will call this undo command that's meant to restore the state of the stage before do happened. In that context, because the actions was mostly to create a primitive and change its attribute, what we do as the undo is we delete that prim. So we remove that prim. Here is an interesting thing for you is we use the delete command. So we create the delete command, but instead of what we call execute, which will execute the command, but I'll also add it to the queue, we call do directly. So do will execute the forward path, but it won't put it into the undo queue. So that's a great way to use the command without getting them added into the undo queue, because of course you don't want that to be in the undo things.
Sorry, could I ask a question there? So
of course.
By doing it in this format instead of the execute function,
yeah,
that's keeping it outside of the undo?
Yes,
outside
exactly.
of the call stack?
So what undo would do is with execute does, when you do the execute pass, execute will take that command, it will add it to the queue, make sure that, and then it will execute it, do the do command for you. That's part of the execute. So this one is bypassing that. So that's a way to execute that without, again, adding this delete command into the queue. You could also very much use USD for that, but sometimes some of these commands are really useful. They do a little bit of bookkeeping. They do a bunch of things that you might find useful. And so in that case, we wanted to show that as an example.
Cool, thank you.
Anyway, so here now is this create point scatter command. You've created that, and then you're able to access it. And then I'll show again where this is accessed and created. It's during that duplicate command. And so how do you call command? So back to what we just discussed. Is the command was registered to the system, so now it exists somewhere, and then you can execute the command. So you call the execute function on the command extensions. You give it the name of that command, and then you pass the parameter, Some of them are required, some of them are optional. It's part of the documentation. Another thing that is interesting there is, of course, this command now becomes available to anybody. So you can register those. So if we were to go to that fun little window that we shared earlier, so you see that now in this window that shows you all of the commands that are currently in the system is the scatter command instance. And so here is the list of commands. So someone that would would look for scatter would have been able to find the command that you've registered. It shows which extension it's coming from, and it shows that if it can undo. There's very few commands that can't undo. Generally, that's really the purposes. But here, effectively, if you wanted to do something that could not undo for the command, you would simply not implement the undo command, right? So if I was to not do that, then this command would not be undoable. It would still be available and execute, but it would not be undoable. And generally, that's not really what you want to do. So you want to avoid doing commands that are not undoable. But here is a good example of commands that then could be exposed. One other things that I wanted to mention there is this little file. So when you create an extension like that, especially ones that start having like utility, right? So they're useful on their own. They're effectively defined these scatter extensions. And then once you enable it, you have access to the scatter window and you can use the tools. But what if someone wanted to use your extensions, not to use the scatter window itself, but to use your command, right? So here you see that the engineer that built that sample, he actually exposed from the init, right, some internal classes to the person that will import that module. So that means that from another extension, here, what I would be able to do, let's see, I would be, in my extension somewhere else, here, I would be able to do import, no, actually, I would do from what's that called, example.ui scatter tool, import, and then here I could import the command that user did, right? And then and you see again our really great Pylance integration. That means that you can see the documentation of that things popping up here and showing. But then that means that your extensions could become some resources from another developer to leverage that tool, right? So if you were to make a set of commands that you would want to store into some utility extensions, you could leverage that platform, and then you could have one places where you store all the commands that you do for your tools, and then just import them from there, so you can have a centralized place to bring them in, and then eventually you can share them on the community and have other developer use your command for their own tools, right? So it's a really great pattern to have, but only things that you expose to the outside world here really are going to be available in that mechanism. And when you do it, you want to start, making sure that you, create a clean documentation and that you define that. And also you have to start becoming careful about your API, because maybe other people will start using it, right? So you have to start thinking about protecting their own code. But certainly that's a great way to be a citizen of the community. Another thing is that this, so we've gone over most of what these samples will provide, really a lot of really useful things. Hopefully you have some interesting questions. One last thing that I wanted to show, Combo Box, and they are due for a bit of an update in maybe 104, but certainly for 105, we will have a new Combo Box update. But right now, they're really powerful, but they also can be a little bit daunting when you're in the beginning of your learning. So here with that sample, we provide a simple combo box model. Itself is not very complicated. You just have to know what these couple of things does. But effectively, what it enables you to do is to create a combo box model that is just based on the list of string. The place where that's used is here, right? This point type, we wanted to have these combo box selections of 3 options: reference, copy of point instancer. So combo box can do a lot of different things, but in that mode they're pretty straightforward, and they still take more code than maybe you would want. So you could also leverage this sample to copy the combo box model that is initializing itself with a list of string, and then it does all of the bookkeeping for you. And then that's what we do in our code. So you'll see in our window where we're in the area where we create, in the scatter area, where we create this combo box. Here you'll see that we were able to just say, here's the label, primitive types. We create a symbol combo box but we targeted to build on that model, and that model was using this one that we just defined, and you see that here it's very simple. So effectively using that model, you can create a simple combo box that will just be built out of a list of strings, and then that will make it really easy. And then later in your code, when you need to access the value, that's the pattern. You get the current item, which is the one that is currently selected, that return this combo box item, and then you can easily convert it as a string. That will call the get element as strings, and then this way you're getting the value that the combo box is. So that's also a great resources. There was some documentation on it. Again, it's probably due to a simplified layer, but you could also use that sample to kind of learn about combo box and making some simple one if you need to. Yeah, I think that's the general overview of what that does. I'm sure Matti hopefully has some questions from you guys that we can go over now.
Yeah, Michael Wagner is asking if you can assign a shortcut key sequence to a command.
Oh, that's a great question. Thank you, Michael. Great to see you here again. So no, but I've got a better answer for very soon. So command tend to take parameter, right? So if you look a lot of those commands, our point instancer command is taking a lot of parameter, right? You see here it takes a list of transform, a list of path names, and so it is generally a command is more like an API. It's not really something that the user can call upon very easily into without passing any parameter. So what we're building for 104 is a new type of object called action. And so actions are really targeted for these things that you want to use for menu or automation, hotkeys. And an action by design is always callable without passing any parameter, which is what you really require to attach it to a hotkey or put it into a menu, right? If I do a create a shape cube, okay, I don't pass any parameter. It's going to be default everything. And so that's what you would do. You would create these actions, and these actions, they will have also an action window, and you will be able to call them from the code, and you will be able to assign hotkey to them. And of course, in some cases where you would want to create an action that leverage one of your command, but passing default parameter, you will absolutely be able to do that. So that's coming for 104. Today, if you wanted to do it, you would have to do it by hand using the normal hotkey actions and create a little lambda. And then you have to make sure that you pass default parameter for all of the one that are having a parameter. If you look at our command here, for example, because it is not designed to be called without parameter, it has a couple of required parameter. You see they don't get default value. So in order to call that command, you need to have a bunch of things that you obviously can't do for a hotkey, or it would be a very sort of simple hotkey that don't that's a bit of a one-trick pony, right? So, but that's a great questions. Action, they'll be really great. We'll show them toward the end of the summer. They're definitely coming in 104.
Cool. Another question is, can you give a name to an undo group?
No, I don't think you can. Let me just verify that. That's a good question too. So we're calling undo here in our scatter, not in our window, in the duplicate. So the undo group, no, you would really be able to do that. I mean, yeah, that's an interesting suggestion. Generally, and I will look what's possible there. This window, it's a little bit of a developer window, right? We could show a couple of things that are actually useful with that while we're showing that. But this window is not necessarily meant for the end user to be able to look at this and trying to understand what this group could have names. So maybe that's useful, but generally assume that people don't really want to be looking there. They just want to do something Control Z. One interesting thing, though, as a developer that you might want to do to discover things. So, for example, let's say I want to learn what's the command to create a distant light, right? And that's an interesting thing. So I know how to do it in the menu, but maybe I don't know what the command is, and maybe I could search, but it's not clear. So what you could do is you can create the light. And then, of course, this action get added to your undo queue. Yeah? So here I've cleared the queue for simplicity, but then I've got this create prim that was the distant light and the code. Now I can select that command, and then here you see at the bottom you have a couple of generate script from the top command or the selected command. So here I've just done that and I've created that prim. So now when I go to the code, what I'm able to do is when I paste, it's going to start showing me that is, imported the command, because you'll need that to make sure that it's run. But of course, you would do that somewhere up. And then here it shows, the kit command execute create prim of type distant light. It shows you some of the parameter, right? Remember that we just talked about that some of these commands take parameter. This one in particular wants to have a light angle and a light intensity. And so here it shows how to pass these attributes to this light. So you can say, oh, now I want a different angle, a different opacity. And of course, you could search for that create prim now into your documentation. So show commands. Here you can create the create prim command. And then you can open it a little bit bigger to see the other types of parameter that it has, the things that are optional, the things that you have to pass. And then there are some documentations. Always remember as well that then you can use that string to search inside all of the extensions of create or code and find all of the places that this create prim command is used in many of our extensions, because they're all written in Python and you have access to them. So that's also a really great way to discover when you find something interesting, to just go and search through the extension link. Remember, this is really easy. I'm just going to show it in seconds for everybody here. Once you have your extensions, you have a link to where the application is, right? So here, because I used the link app, it linked the app that I was using. Of course, I'm using code. And so here I've got all of the things that are in code, including all of the extensions in that app. And so now I can go and search. And then if I look for create prim, by default, you will only find things into your extensions. And that's because the way VS Code is constructed, it doesn't search into things that are excluded from your Git repository. And so because, of course, this code here of the apps that is linked is not inside your repository, because you want to exclude it from checking it in. What you can do is you right-click, you say find in folder, and at that moment you search into that folder. And now look, I've got a really handless things of really interesting moments where people create prim. And so if I wanted to say create prim, then I could find all of the places where people have called create prims of type sphere. And then you will find really a lot of really great examples. So that's a really, really good way to go from something that you want to know, the very basic example, and then find its usage, find its actual implementations. Most of those will be completely available to you in their Python form, so you can learn how these commands have been built and copy them, or you can see where they've been used for. For example, just take this command prims distant light. So here I'm just going to use that because most times it will be in that form. I can see that mostly this form was used in a couple of tests and in the documentation in USDMD. Probably because there's a couple of different things the way it's structured in the code, but really a great way for you to go and find code inside the applications, and because here are all of the extensions that you are using that are all in Python form and they're all searchable.
Yeah, that's a great tip. I'm still getting used to using VS Code, but great to know that you can search from within VS Code all of the app code.
You can do that, and it's actually a really great way. Like the past weekend, I was building something to show some engineer team, and then I'd use that all the time. Right, you just go and effectively have hundreds of engineers' code at your fingertip that you can really learn from, and kind of either copy or modify or understand better the concept. It's super useful.
Cool. We have a question from David over at Studio Galt, who's working a really interesting app with Omniverse using sign language, trying to teach sign language. His question is it possible to lock certain assets to certain users, make it so only certain user can affect simulation or lighting?
So in a multi-user collaboration, you're in that nucleus type of world, right? So at the moment where you're doing multi-user collaboration, and so that's I preface that so people understand the sort of the differences of my answers. But so you're on a nucleus server, and then you have one files, or you have a set of files, really, right? USD files, and then multiple people connect to that one set of files and are able to modify it in real time, and each other view what's happening. Generally, in the current version of the collaboration stack that we have, what you do is different users are on different layer. They affect a different layer of USD, so their changes are quite self-contained. And it also helps with performance, and it helps with people not colliding on their changes. This is changing slightly. We have a new things that's called Omni Object that's coming, and we'll talk about it in the future when it becomes more generally available. But the way you do some of these locking is generally by doing some things called auto-authoring. So yes, it's possible. I think it'll be more easy to talk about when everybody's got access to this new collaboration technology. But it's possible today. It's just you just have to lock this different layer with ACL on your nucleus server. But again, it's a bit more of an advanced topic to discuss in that call.
This sample is pretty cool because I can imagine some people just using it directly, but it's even more cool because of all the primitives that are in there, like the patterns that people can reuse for other tools. If we're really talking to tool makers out there, boy, what could you make with this, right? And you can think about like in the movie industry, how do you make sets and stuff like that, and make tools for set designers to go build out some cool stuff? Or in architecture, how would you help around the construction site, or in manufacturing and robotics, and you just keep going. And so I think for tool makers, you sort of think along two dimensions. One dimension is, do I have deep understanding of a niche scenario that is unserved, right? And can I build tools that are very bespoke to that niche scenario and will really help complete the workflow in that thing? So maybe you know a lot about architecture, you know a lot about TV sets or whatever it is. That's a really great, powerful tool that you could make, and you could use a lot of the primitives in here to do something really cool and bespoke for that. The other dimension to think along is, can you build a primitive or a component that can be used by a wide range of tool makers in turn? So in this, Damien showed the command, for example, and you can also do that with UI components. You can make a complex UI control that other developers can use. That's also a very valid dimension for tool builders to go after and build, and you can learn a lot of those patterns from this sample as well. So like one thing, when you're looking at these samples, remember these are samples and they're meant to inspire, not features that are going to be awesome to use, although it might be an awesome feature to use for somebody. But as a tool developer, like tear it down and look at the patterns and start to think about, how can I mix and match that in with my own ideas and my own use cases to make something broad and big.
Yeah. No, definitely. Yeah, that's a very good point. And so, and also, we're building, them. We're going to build more. Continue to engage with the community, with the Discord channel on the various forums, to say, I'm trying to do these things, but I'm looking for more examples. We're working constantly on improving the documentation in general, but these samples are also a really great way to get started without having to read a lot of things, right? You can start learning the pieces that you need, or just copying and not necessarily always understanding the pieces that you just want to use as is, right? This combo box model, for example, you could just copy that files and keep it around, and then just use it as it is until such day that you're interested to build a more complex combo, and then you want to learn about how to use these things. And so I think those are interesting component. So really in that samples, you'll learn about how to just continue to leverage the window sample that we shared to just modify it simply to get to your window. It shows a little bit how to use these model, string model, int model, to back your different properties in simple forms to be able to connect them and get them. It shows how to expose here in the init how to expose either, a window. Here we actually expose that window. I'm not sure exactly that we want to do that, but you might, expose that window to other developer, or here expose that command. You certainly would like to do that. It continues to show that you can use style to contribute and customize your windows. And it shows you how to build the simple commands alongside using commands into your own code to do things that are, see, that's here in the duplicate prims, that you want to do modifications and how to use those and use the command group. So there's a lot of interesting learning into that sample that we'll make available, I believe, this week. And remember, it was really in order to do that setup and share with you today. The only thing that I did and you're able to do for any of the samples is I grabbed one of the sample. Again, this is private just right now, but it'll be public soon. I cloned it. I went here. I cloned it to my drive. Then I run the link.app that is at the bottom, in the root folder, linkapp.bat. You just have to make sure that you have the launcher running so you can find which version of code and such that you have installed. It automatically generated that link for me, which is the link to this folder, right? This is a symlink that goes into where the actual file is. You see here, Kit repo, create extensions app, and then this way the project was entirely set up to just work. And then in code, the other steps that you want to make sure that you do is in code, you need to, in order to be able to see that extensions in showing up inside your world, you have to update the path of your extensions. And you see here what I did simply, and then last week we had done the scene example. I just added a new folder to the list of extensions that were on my system, and I pointed it to the folder where the extension of that repository live. And by doing such, these things would appear into my extension manager, and I was able to enable it and then demonstrate it to you.
That's great.
Awesome.
And if folks out there are building really cool tools based on this, if you tag it in GitHub with the Omniverse Kit extensions topic, and particularly if you mark it a release, we'll notice it and we'll check them out and we'll give you feedback, and we're happy to brainstorm with you. And other people in the community could find them and use them as well. And so then they'll be able to get your stuff out to folks. So yeah, tagging it with that topic and marking the release will.
You'll see that there is already a lot of people that have started to.
And it's growing every day. Like now there's 24 and there was 22 last time I looked on Friday or Saturday. So great.
That's awesome.
Great.
We also
Any other
have,
questions? A few things that people want to kind of ask before we wrap this amazing show?
Well, a lot of good feedback. I see fantastic session. Thank you so much. That's pretty common around here when Damien's on. We also, for support though, if you need extra help or you want to chat with other users, the forums are a fantastic place to go. And if you, especially if you're having technical issues and need help there, if you want to chat with other users, I would say Discord is probably a better place to hang out. The devs do hang out there too. Maddie's on there all the time. Damien's on there. But we don't have a way to track things on Discord really. So for official issues, go to the forums to chat with other users, show off stuff, go to Discord. We actually have, gosh, I think 10 channels now under developers that are specific to a different area, whether it's Warp or microservices or extensions, connectors. So find your topic there, and you'll see it's a really, really fantastic community that's growing every week. Super helpful. I find people are helping each other a lot, which is great.
On that one, if there's somebody out in the community that has maybe a local developer group or Python community or a 3D, whatever, a community where they want to learn how to build extensions, I'm looking for one or two community leaders who have that group, and they would love to have us come do a workshop with them. We would love to walk them all through it and then have a little session where we can answer questions and all that good stuff. So anybody out there who's got a community, let us know. We'll come to your area, and maybe virtually come to your area, depending on where you are. If I have somebody in town, we'll go in person, but it'd be great.
Awesome.
So to get in touch with us, what would be the best way? So
yeah, just hit me up on Discord, I think is good. Yeah.
Okay, there you go.
Redmar, what were you going to say?
Well, you could. So Discord's great. If you can identify, I think our names are here. But you can also go to email if you want. You could send an email. Mine's easy because I had IT do an easy alias. So you can just do edmar@nvidia.com. So edmar@nvidia.com, and then I'll forward it to any of the developers on the team. And that's really easy. So.
Yeah.
That's it. Now you
Awesome.
could create amazing tool. 250. You could probably do more. I'm just being shy here. 250 billion polygons in ray trace. Actually, I switched it to HD. Still very happy to go. So we're really looking forward to see what you're going to build using these awesome tools.
Awesome. And if you're just getting started, you can download the Omniverse Code app that Damon's been using. That's a great place to start. It's our IDE. And Paul Cutzinger has a video on YouTube about how to build an extension in under 10 minutes. That's also a great place to start. We have documentation built into the Code app. We also have the Developer Resource Center, which we'll link you to. That is also a good place to learn more about developing for Omniverse. So with that, I think we're done.
I think we did
Actually,
it,
Damien,
guys.
why is it darker in the middle there? Is that the size of the plane? You went bigger than the plane that you built? Is that what it was?
Oh yeah. We just went.
You spawned beyond the planes.
He's off the grid.
They didn't. The 1 million pound didn't fit on my small little 1 kilometer square plane. Sorry.
So big you can't fit into both eyes at one time. I like
I
it.
know. Where will it
That's
stop?
awesome.
We'll be back actually tomorrow, back-to-back live streams. So we'll be back tomorrow with Brian Harrison on our team and special guests from Esri. And we're going to be looking at getting started with architecture workflows and design review. And we're lucky because Maddie, you know a lot about this, don't you?
A little bit.
And I think you have a couple videos I think that we have going over Esri City Engine.
Yeah.
Right, so that's one of the things we'll be looking at tomorrow on the live stream. So it should be a lot of fun. So anyone who's looking to get started, we're going to go over the workflow, answer questions, do some nice show and tell, and have some very special guests from Esri join us. So that should be a lot of fun. Exactly 23 hours from now. So try to sleep, eat a little bit, and then come back.
They
great.
can't
No,
sleep
don't
now.
sleep,
They're too
Maddie, don't.
excited.
Like-
Yeah, it's like Christmas,
Yeah,
right?
who's going to sleep when they should beat my 250 billion triangles? They're going to go crazy trying to help me. Post your picture on the forum or on Discord. We want to see how many
yes.
polygons you can put into your card.
Actually, yes, do that. All right, guys.
Thank you, everybody.